From ContainerDays Hamburg, this video is proudly presented by Dux IT.
So, just a few words about me. I currently work for the company called Vrike. We do software as a service, and I am a part of one of the infrastructure teams. Originally, I have a strong background as a developer a long time ago, but I moved to the infrastructure field, and we worked with a few clouds along the way, I would say. So, I have a story to tell you and to guide you through, let's say, a small journey that I've personally witnessed on multiple projects combined. So once upon a time, there was a demand to run your cluster and resources, of course, more effectively, right? Then the first thing you typically do, you go to YouTube, you go to ChatGPT, you go to your favorite vendor and ask them, okay, how can I do such a thing? And they all say the same thing. It's super easy, you know. There was a session just today from Christian and Jan, and it was so easy that I would like to do it, you know. In the next minute, I would like to start out and just try it. Everything scales from the node level to pod level so seamlessly, right? But maybe it's not such a fairy tale, I would say, because if you are running just Nginx in the demonstration and in examples, everything is super nice. Nginx has, I don't know, 5 megs of RAM footprint if it starts as a blank container, something in this direction. But maybe you are running some real applications. They may take probably a minute or two to start up. Maybe the applications are not ready, like once the pod says they are ready, because they have some caching thing to do from the application logic perspective. Maybe you have some additional archives that have some extra complexity where starting the pod up. So you maybe need to take a look at your probes at the first. Typically, what you can do pretty easily is scaling up, right? Especially in cloud, there is typically no limit on how many VMs you can have. So let's just like buy 10x of them and let's scale up. This is super easy, super fast. And now in the story, you are typically like seeing that you have a vast majority of the capacity completely unused. And at this point, you typically understand, okay, I don't have a good monitoring system. I don't understand how my application is going to behave. I probably don't understand if my application needs loads of CPU time or is memory bound, or maybe it scales on some completely different metric that I am not yet aware of. And I can tell you that I have seen this story like many times, and it is like absolutely typical, I would say. So the people don't understand what they are running unless they really need to get their hands dirty with it. So if you are able to scale up and down the pods, now there is a second stage of your endeavor. And now you understand that you might have a problem scaling nodes, which means that you decide to scale on 2 additional pods. You need a new node to spin up. But suddenly there is a twist, right? The node needs several minutes to start. Like throughout my observation, I can tell you that it's not like 30 seconds you have seen on the presentation, typically, if you have some workload there. So I would say 2 to 10 minutes. And if I'm saying 10 minutes, this is no exaggeration because I've seen it, for example, on the Oracle Cloud. At the end of the day, you may find yourself in a situation when you will like to check how your applications are doing, and you will see something probably such as there are many nodes that have just single application VM, which is standing there still, but the nodes are still running, again, probably 90% unutilized, something in this direction, very typical. You may be hit by some events. For example, you run an e-commerce site, it's Black Friday time, so your maximum capacity needs to be really 10x, 20x higher than your like regular workload time. It can happen that the developer will release something completely new that has a different performance patterns that you have seen previously. And what does it mean for you? You can start all over again. So the maintenance for any solutions is definitely not free. And I have personally seen a nice example where there was a change in the application that basically over the weekend, like spent all the money that it saved several months before it, just because the autoscaling was configured such as this. So after this endeavor, after this journey, where are we at? There are some hidden caveats. So for example, if you would like to scale on the Prometheus metrics, you need to have multiple Promethei. Typically, if you have some additional infrastructure, for example, Knative, you may also need to understand much better service meshes because it is one of the requirements. And also, all those technologies do not come for free. So, for example, for KEDA, for Knative, there are some additional components that might be a bit flaky along the way, I would say. So in the end, you will get a lot of new cool stuff to play with. That is for sure a nice thing. But you also have a new cool stuff that you will probably need to run for multiple years. And this is not that funny. I would say that if you start on your autoscaling journey, it typically goes like through these steps. So scaling up is the easy thing. Everyone in the demonstration can show you the scaling up thing, not a big deal, right? Then you understand, okay, I probably need much better monitoring because typically you don't understand how your application behaves when it scales up. What do I mean by it? You need to decide typically if you can or cannot scale down because maybe you have excessive capacity and you would like to save some amount of dollars along the way later on. And this is not an easy thing to do because if your application is running on 10% of CPU utilization, can you scale down so other instances like can take the load? Or maybe do you need more memory checks before you do it? Or maybe is there some, yet again, other metric that you scale down upon, etc. So what is an important takeaway from here is that the scale up and scale down are completely different disciplines, I would say. The scale down is probably and typically like much more difficult. Also, you will get very strange errors from your pods when they, for example, terminate long-running requests and such. Scaling to zero is the cherry on top of the cake. I've seen a lot of questions today on scale to zero, but I would suggest this is really once you can really like try to think about it only when you are finished with the previous steps. Like if you are down there, scaling to zero is probably not yet your thing. And once you will discover how does the pod scaling work and you will become partially an expert, there is a node scaling problem, as I mentioned. So I would suggest maybe a slightly different approach. And I would say that the autoscaling is a tool that may save you some bugs in the cloud. On-prem, I completely like rule out any usage. I wouldn't suggest it. Maybe it's a bit controversial, but sorry, that is at least my experience there. And let's take a very silly example of what is our reaction time. By the reaction time, I mean that we typically need a new node to come on because we are paying on the node basis for our cloud providers, right? It takes 2 to 5 minutes, 2 to 10 minutes. Typically, your application needs to pull the image. It needs some time to boot. And like overall, so the application, while metrics will change, it takes some time for the measurement also to progress and like understand, okay, I have a new pod now. The conditions, for example, for the request distribution, etc., are slightly different. Also, you might run in some like nifty technical details that are not apparent at first. I have a very nice experience understanding that, for example, C-Ruby implementation is not multi-threaded in the end because there is such a thing as a global log. And basically it means that you have only one thread, but of course you may have some other like bottleneck there. So it all boils down to one simple thing. For your application, do you really understand how does it perform? How much traffic does it going to get tomorrow morning, over the weekend, etc.? Are you mixing slow and fast requests into the same endpoint? Can you differentiate them between them? Because you probably would like to have a different scaling strategies based on it. Also, you are not probably scaling only on the customer-facing HTTP traffic, right? You probably also have some queues and or some batch jobs, and you would like to scale them maybe too. This is a separate discipline, I would even say. Do you have a spiky traffic? We typically do, at least for the customer-facing services, we typically do. And this is yet another challenge. It all boils down to the question what is your current efficiency? So if you have a cluster already, and I guess that most of us do, we don't run a single application, right? For the applications we like to scale, what is our efficiency and what can we really achieve there? So people typically don't well understand the performance profile, and I would probably suggest to talk about something called saturation. This is one of the golden signals, and this is, let's say, one of the approaches to monitoring in general. And this is, let's say, the understanding of what makes your application full in a sense. By full mean that it cannot take much more load. And you can have it in many directions. You can say, okay, my application can take, I don't know, 10 slow requests, 100 fast requests in a minute, in a second, etc. You can divide it by memory, etc. But you need to understand this pretty well. And the problem in the monitoring is that it's not visible. So it's visible only like that the application is progressing, and for some reason now it may stop taking any more requests, and you don't have any nice progress bar 0 to 100% where you are currently at. So let's align our expectations. I would say that typically the baseline of our applications are somewhere between 10 to 20%. This may be a bit controversial, but you will see an example later on. If we are at a peak capacity, meaning that we really need to handle some peaks, we can get to 40. Maybe if you are a super efficient company, you can get maybe to 60. Also for small applications, 3 node minimum to have highly available application is kind of a problem. And overall, you really need to ask yourself, how much time do you have for this effort? So this is one of the examples I have. By the way, sorry, but this originally was intended to be a hands-on workshop, so you can try it everything yourself. But so I have a few examples that I've intended to have there. We have 4 different lines. The green one is how many CPU we have on the node level. The orange one is the CPU request for the entire cluster, all the applications there. The blue one is our application. So you can see, for example, that there is already a large gap between our application and the whole cluster request, because we run some auxiliary infrastructure there, right? And the gold one, yellow one, this is our real CPU usage. Wonderful, right? So we are in a cluster. We have many scaling events, and you can already see that the efficiency of our application is probably not that great. And also, it's very important to understand from this picture that how far can you get? Maybe to those 60% I mentioned, but there will also be some bump between what your nodes allow you to do. There will be some gap between what you have in the infrastructure. So some rough numbers from a small application, really. If you have larger applications, typically those numbers get a bit better because you don't have so much slack for the infrastructure, but it's still, I would say, not that great typically. So our application is CPU bound. It has a large amount of small requests, right? And from what you have seen, around 5 CPUs are just requested for the Prometheuses, Istios, whatever is there. We have 26 events for scaling in 1 day, meaning that there are 26 occasions where there is a rebalancing of traffic, reshuffling of many things, and some things can break during that 26 events per day. So let's maybe go to some scenarios and let's discuss what you can realistically expect in those. First, we are running the same workload for a long time, never touched it, never discussed its efficiency. maybe just go there and do some one-off discussion how we can scale the resources down. It might be sufficient. Maybe you can revisit your workload every week if you would like to be super efficient. If you have some typical working hours and you know where your traffic will get to, maybe something much simpler than autoscaling can help you, right? That is more predictable for people around you also, for example. But let's imagine the scenario where any error, or the business at least says that any error is a major problem. And this is heartbreaking, meaning that you cannot do much about it, right? You need to scale, you need to be prepared, and you cannot take any error. It's of course not going to happen, but at least the business says so. So these are some of the scenarios that I would say are suitable for autoscaling. And if you are not there, maybe there are some others, but really you need to understand the scale of the thing. So if you are processing queues and you don't care about the latencies, yeah, let's try autoscaling. If you have unpredictable traffic, again, maybe you have varying traffic, so it's really hard to predict, but there is some variance on it. Okay, at least. If you are selling some, let's say, concerts for large scale, etc., probably I would say that if your application is smaller, typically any appearance of the Hacker News means that you are being DDoSed from your regular users. It's not like scaling at all, because the difference could be really up to 100 of requirement there. I have one interesting experience also with moving from AWS Lambda. So if you have some serverless offering on the cloud provider side, people typically would like to move it with a similar experience. So autoscaling is enabled by default. How to approach such a project? I would definitely suggest to start with the data gathering you already have, because you typically have a lot of data. You can see your application from multiple times. You can check its seasonality. You can check what is the difference between each container state running, etc. And it really helps to set up some expectations that you can really satisfy, and not just iterate, and after 5 months said, okay, it's still not perfect and we need to drop this off. First approach is to use cron, right? Because you have probably some predictability of the traffic. You typically have some understanding that there are some working hours time, and maybe you can scale up. You can probably also try to use some very simple mathematical functions to estimate what will be your traffic tomorrow based on the data from the last 30 days. PromQL, for example, in the Prometheus has a lot of options there. It's not AI, it's really simple mathematics, and it works very well. But from my understanding and my experience, people don't use this unfortunately much. Or maybe you can go with some AI tool and that will predict for you. Why not? But I haven't seen such, to be honest. The big benefit of such an approach is that it is not reactive, meaning that if you are predicting what traffic will come in the next hour, you can be prepared in time. And this is one of the very positive things about this approach. Cron-like scaling. So imagine that instead of making autoscaling working with a lot of effort on tuning, we would have 2 cron jobs to scale the nodes up, to scale the pods up, and then do yet another 2 to have it vice versa at the end of the working hours. Is this fancy? No. Does it work? Very well, I would say. From my experience, this is what the companies typically, in 80% really need, because it is highly predictable. We can discuss what's there should be. And also for the business people, this is, they can understand the pattern. So they are able, on their level, to discuss with them, okay, we are not talking about the amount of 502 errors. We are talking what are our working hours. And we can give you a clue. Why not? Very simple and effective strategy, unfortunately not that sexy. What strategies for autoscaling do we have in default in the Kubernetes? So first is what is called VerticalPodAutoscaler. Basically, on your pod, you can increase the CPU request limits, or you can do the same for memory, right? Well, no. By default, in Linux at least, you cannot scale down memory. So the only like reasonable use case here is if you would like to increase the memory limits up. And there's a question, why don't you put the new threshold as a default for the container? So I would say that at least I haven't found this useful in my use cases. Next to it, there is a HorizontalPodAutoscaler, HPA, which is much more interesting because it, of course, allows us to run multiple replicas. It is based typically on the either metric server of hotel provider, let's talk Prometheus, so you can have CPU, memory, or any other metric. It's typically easy to set up, and it works well when your request flow is uniform, meaning that you don't make slow and fast requests. Everything is roughly of the same size. If you add 2 pods to yet another 10 running, they will have a similar performance. In these workloads, it works, I would say, acceptable. When I say that there is a reactive component to the time, what do I mean by it? So this is a small example. How much time does it take without spinning a node to react? So first of all, the reaction takes some time to progress through the metrics, right? So we probably need several measurements until we decide to scale. Once we decide to scale, it turns out that it's not like one-off to start a container, right? It takes some time. So the pod needs to be scheduled, image probably needs to be pulled, maybe it's pre-pulled, okay, but still your pod needs to start up. So you will have probably the reaction in 2 to 5 minutes. And you won't cause the traffic spike that was like already probably happened and is not there anymore. This is very typical, I would say. So what are some problems that you encounter when you like use HorizontalPodAutoscaler? Typically, you are like acting on some average metric. I will show some examples later on. If you have any problem with the memory leaking, or for example, that the CPU is going up, there is some problem like in the technology, I'm in Java, for example. So the memory is not released, and you basically cannot like estimate what is happening inside of the pod based on the memory. This is then completely useless, and you need to find some other, typically very internal metric. And the last problem I see is that those patterns with those low-level settings typically create like very complex holistic system behavior, which is like hard to debug, hard to understand. What do I mean by it? So this is a simple average example, right? We would like to have scaling, and we would like to prefer have our pods about 50% of memory utilized. As you can see, our application probably just increases the memory since the startup. And if we average multiple values, we, strangely enough, as in average, we get some value that does not represent much, meaning that there are pods that may be running already for several hours. They might be in some certain state. Maybe they are a bit crippled already. They are not able to serve that well. And we have a completely fresh, young pods next to them. Again, on the average is just mathematical average, so it doesn't tell us much. So for this application, memory is completely useless. What about CPU? The same scenario here. So the CPU application is the application is not bound by the CPU metric at all. You can see that the CPU never goes higher than, I don't know, 20%, 30-50% in this example. This is because the application is really bound in the database, for example. The key question is, if you understand it for your applications, and if you are able to set it already correctly, you almost won. If you're not, which is typically my use case, I really need to understand, you will need a lot of data, a lot of experimenting to understand it. Let's take some more complex examples with the HPA, and yet again, like showcasing all the capabilities it has. So there is a scale down policy, which is different from the scale up, as I mentioned. Those are typically different disciplines. There is some stabilization window, which means that inside of the window, you can spin up only a certain amount of instances. This is typically some burst overall protection, because let's imagine that somebody will start like bombarding your API endpoint with 2K requests at certain amount of time. Even though it mathematically makes sense to spin 100 new pods, you typically don't want to do it. And you want to scale up, let's say, in some steps gradually. For example, the same thing happens when you go down. You typically want to be very conservative on the scale down procedure. You don't want to rush it, because what can happen is that you will have some 5.0x errors there. We can scale on multiple metrics at the same time. So here in this example, you can just see the CPU, and the PAMA running means this is some Rails proprietary, let's say, metric. It's 3.8 threads on the server, something in this direction that we would like to achieve. If we go away from the Kubernetes options, there are some projects that can help us along the way. So first of all, I would like to present Knative. There are multiple projects in the umbrella. I would like to talk about the serving part, which is significant to us. So what it does is basically that it allows you to have a queue in front of your service. It allows also scale to 0. Wonderful. And there are a lot of details that basically are some kind of protection from bursty, spiky traffic, which you will really evaluate very highly once you see what it can do to your workloads. It has a tremendously good observability, I would say, so really can get down to the bottom of those decisions under scale when the scaling events has happened pretty well. And for the developers, it offers some simplified, let's say, YAML, so they don't need to have the whole deployment quite long typically, but they have some simplification that they offer for them. There are some limitations, of course, to the Knative. First of all, is that it requires you to run service mesh. It's not technically correct because there is some, let's say, special definition called K-ingress, but only 3 service meshes are currently supported. Originally, as I mentioned, given that they have a different YAML structure than the pod level, let's say, defaulted by Kubernetes, they didn't allow sidecars to go in. They didn't allow host networking, for example. This is already fixed. And they allow you to expose only a single port, for example. This is the architecture, and I just want to showcase you that what you are giving inside is basically your container or containers. This is the golden color, and everything in blue is provided for you. So there is the activator component that is like a proxy, keeping the request until your service is allowed to start from 0. There is a queue proxy which really acts as a queue in front of your service. So why I'm talking about this? The first thing or for benefit here of Knative is that you can define the metric based on number of parallel requests. This is typically very well aligned with how your application is internally designed. So there is some database pool, some thread pool, etc. that is inside, and you can match these numbers together. You can, of course, simulate what AWS Lambdas does. There is no concurrency, for example, is in Lambdas as some form of simplification. You can have it, and it can also affect your service, so it is much more, let's say, transparent and simple. Requests per second is typically why people would like to try Knative, but again, I feel that most of us don't understand what requests per second our services can handle. At least I cannot tell, but people typically have a notion that this is much better metric than memory or CPU. In practice, I don't have such an experience, to be honest. The activator component, maybe just an emphasis on that scale to 0 function, is something that can basically cache your request and wait for your cold start of the application. The cold start typically has 2 components, image pool, and then you need to run the application. So for example, if you would like to boot Java application that has 90 megabytes, it takes 9 seconds on the modern CPU, I would say something in this direction. And you also need to count this in. In my opinion, probably very controversial after those questions I've seen earlier today, it's definitely not worth it. Maybe for some very niche use cases, but typically you spend much more time debugging this and understanding what is happening under the hood than what it brings you in terms at least of savings. Let's have some small example here. So I will have a Knative with the scale to 0 functionality, and we will throw 1,000 requests at it. There is a setting to allow only 1 request inside, 1 parallel request at a time. So we are starting from 0. We will kick in all the requests. You can see that the containers are starting. They already are in different state right now, even though the images are pre-pulled. and after 7-8 seconds, they are up. So how does it look like from the benchmark perspective? There are 20 requests that took more than 2 seconds. This is the cold start. The most of the requests are much faster. But already we have introduced very complex behavior because the request time depends on the cold start. And if you have some SLIs, SLOs defined of like P99, you may already have broken them. So let's discuss very briefly. There is another project called KEDA. And this is something like, I would say, HorizontalPodAutoscaler version 2. It's based on some event-driven decisions. It offers HTTP support, but definitely not at scale as I've seen in the Knative. Under the hood, HPA is used for the scaling, but it is completely invisible from you as a user or a system administrator. Typical use case is that you have a queue that is not customer facing, let's say, and you need to scale based on the number of messages. So for example, here we set something to Kafka queue, and we would like to scale number of consumers of the queue. This is taken from some real application that does automation. So customers probably like to set some automation each hour. Okay, so we can satisfy them in some, let's say, dynamic manner. Why not? The event you can imagine as basically any form of YAML, JSON, whatever. There is like probably several dozens of providers. So either from the other components of your ecosystem or from some cloud provider, software as a services tooling, you can basically scale on any event you can imagine realistically, I would say. You can even use KEDA itself to produce cloud events and then consume them to have some more complicated workflow, meaning that you, for example, have several like layers in your application. And when the first layer is already hit by traffic, you can scale several others in the follow-up scenario. Okay, this is again a short introduction to the HTTP add-on of KEDA. So it allows you to have a similar scenario, scale to 0, have some queue behavior in front of your workload. And the main reason I'm showing this architecture is that again, it works in a way that it puts something in front of your service. So it's definitely not free. It's not much about the overhead, but let's say about the complexity of the service you run on a debugging, and many like other details that might hit you later on. If I would compare, at least from my experience, KEDA HTTP add-on in comparison to the Knative, I would simply say Knative typically works better for the majority of advanced use cases, but for some simple ones, I think that KEDA HTTP was completely working okay. You don't also need a service mesh, so for some simple workloads, simple clusters, this might be definitely beneficial. And if you have KEDA for other use cases, why to switch to another technology for sure. So I would definitely suggest, if you would consider scaling, to go over these simple steps that are probably like very obvious. But first thing is really the most important one, setting reasonable expectations of what you would like to get in terms of percentages, SLI, SLO, whatever. Just set something that your business will be content with, and you won't iterate indefinitely in this like never-ending fight, because it is really a never-ending story to autoscale perfectly. Definitely try the technology you would like to work with, get some hands-on, understand it. Sorry about switching from workshop to session. And if you would like to introduce it, definitely install it with like no functionality whatsoever. I mean, configure it in a way that it does not do autoscaling, then do small steps and iterate on your observations, because you will definitely need to bump up, improve a lot of things along the way, I can tell you. Again, I'm promoting cron-like manner of scheduling, because you will see later on, if you may have some experience, this may save you a lot of time. The reaction behavior is 2 minutes at best, and really I need to emphasize at best, it can take much longer. If you go to any advanced method, I can promise you that you will scale an enormous amount of time just tuning those parameters so it behaves holistically as a system as your business expects. And a short summary, maybe cron-like manner will solve you up to 60% of your expectations, and you can have it set it in one day. If you have a good metric, why not to go with HTTP or KEDA already? If you have a queue processing workload, definitely this is a job for KEDA. And if you are solving, let's say, advanced or semi-advanced scenarios from the user traffic, definitely try out Knative. That's all what I had.
How to choose between VPA and HPA scaling for an application?
HPA, we don't consider VPA unless you have very niche use case. As I mentioned, I think that it's not worth your time to consider CPU scaling at all, typically. We can discuss this much more in depth if you like. I'm available. So you can only scale memory up, and in that case, it's typically not worth it. So HPA for sure.
Next one is, thanks for sharing your experience. Do you often hit GitOps challenges with scale down, scale up resources? We do with KubeGreen.
Sorry, not sure about what KubeGreen is, but yeah, for sure there is a small detail. Let's say that in Argos CD, the number of, or the attribute that signifies number of replicas, it is different depending on which YAML we are talking about. You need to ignore it. And then it's, for example, interesting when you deploy a new version of application, because of course one of the typical beginner's mistakes is that with a new application deployment, you will skate to what is a default value of number of replicas in your Helm chart, for example. So yes, there are some challenges, but yeah, I would say that you can solve them early on, typically.
Next one is, can KEDA and HPA live together in shared clusters, for example, EKS, so that application teams will have option to choose? Yeah,
sure, because as I mentioned, they need to live. KEDA needs to use HPA behind the scenes. So if you define wisely that they do not collide, they do not interact on the same namespaces, objects, or whichever way you prefer to split your workloads, teams, or organizational structure, yeah, sure. Why not?
Okay, ever used horizontal and vertical autoscaling at the same time?
Yes, I've tried. After 1 hour, I've disabled it. No, it does not work. Sorry.
Which application has been used for benchmarking request performance for Knative approach?
I think it was K6S, or was the name something like this? But I'm old guy. I also have Apache Bench, in my toolbox.
Next one is, what would be some application example where it makes no sense to autoscale?
Postgres, for example. I've seen a Postgres t-shirt somewhere around our crowd on a previous session. Postgres is a nice example. How can you scale databases, for example, if you don't understand what is the intimate details of how to replicate data? So if I have one Postgres instance, does it help that I create 9 more? No.
Some methods to prevent oscillations? Or oscillation? I am not sure how to pronounce it, I'm sorry.
Well, in my presentation, I probably address this as a spiky traffic or burst. Yes, for example, the stabilization window on the HPA helps you define some limits. How many pods can you scale up and down in a single instance, no matter how the mathematical calculation will look up. So let's imagine that you have some burst, let's say some attack, and you will scale to 100 pods. Then, even though after the next 10 minutes you drop to regular traffic and would like to have only 10 of them, this works in a way that it allows, for example, in 60 minutes, or as you define, in 60 seconds to scale down only 4 pods. So you will see some steps down, in the direction of down, and it will take some time to get to your bottom line on standard. You can use typically the stabilization window in both directions, because yet again, I've mentioned the, let's say, attack scenario. If you would like to just fail on some request while going up, the same thing is possible.
Okay, that was the last one. Thank you so much. A big round of applause for David.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.